Hello everyone. In this question, it is said that if alpha, beta, gamma, delta satisfy the condition that alpha plus 1 whole square plus beta plus 1 whole square plus gamma plus 1 whole square plus delta plus 1 whole square upon alpha plus beta plus gamma plus delta equal to 4 and alpha plus 1 upon beta minus 1, comma beta plus 1 upon gamma minus 1, comma gamma plus 1 upon delta minus 1 and delta plus 1 upon alpha minus 1 are the roots of the biquadratic equation a naught x to the power 4 plus a1 x cube plus a2 x square plus a3 x plus a4 equal to 0. Then we have to find the value of a2 upon a naught. Okay, so let us first start with the given condition. We are given that alpha plus 1 whole square plus beta plus 1 whole square plus gamma plus 1 whole square plus delta plus 1 upon whole square is if we cross multiply, it is 4 times the sum of alpha plus beta plus gamma plus delta. Okay, now on opening the squares, we get alpha square plus 2 alpha plus 1 plus beta square plus 2 beta plus 1 plus gamma square plus 2 gamma plus 1 plus delta square plus 2 delta plus 1. This is equal to 4 times the sum alpha plus beta plus gamma plus delta. Okay, so if we take all the terms to the other side, we will get alpha square. And this is 4 alpha plus 4 beta plus 4 gamma plus 4 delta, right? So if we take it to the other side, we see there is plus 2 alpha and this is minus 4 alpha. Okay, so this will become alpha square minus 2 alpha plus 1 beta square. Here it is plus 2 beta. If we take this 4 beta to the other side, it will become minus 4 beta, right? So it is minus 2 beta plus 1. Similarly, the third term will become gamma square minus 2 gamma plus 1 plus delta square minus 2 delta plus 1 equal to 0. Now this first term becomes alpha minus 1 whole square plus beta minus 1 whole square plus gamma minus 1 whole square plus delta minus 1 whole square, okay, equal to 0. Now assuming alpha beta gamma delta are all real, this is a whole square, right? So this is positive, this is positive, or at least non-negative. Okay, this is non-negative, this is non-negative whole square, this is non-negative, this is non-negative. Okay, so the sum of 4 non-negative terms is 0. This implies all of these terms, each of them has to be equal to 0. This has to be 0, 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 because only 0 square plus 0 square plus 0 square plus 0 square will give you 0 for reals. Okay, otherwise this is all positive, and sum of 4 positive numbers can never be equal to 0. Okay, it is something greater than 0. This is also will be a positive number. Okay, so if each of these are equal to 0, this will imply that alpha is equal to 1, this will imply beta is equal to 1, this will imply gamma equal to 1, and this will imply delta is equal to 1. Okay, so we got alpha equal to beta equal to gamma equal to delta equal to 1. Okay, from their given condition. Now the roots are, let's say, let capital A is your alpha plus 1 upon beta minus 1, right? So plugging in these values, we see this is 1 and 1 upon 1 is 1 minus 1. So this is 1, right? Similarly, if we take capital B equal to beta plus 1 upon gamma minus 1, this is similarly 1 plus 1 minus 1. This is 1. Similarly, if we take capital C equal to gamma plus 1 upon delta minus 1, this is 1 plus 1 minus 1. So this is also 1. And lastly, capital D equal to delta plus 1 upon alpha minus 1. And this also becomes 1. Okay. So we see all the roots of this biquadratic equation come out to be 1. Okay. So the equation the biquadratic equation that is given, it is a naught x to the power 4 plus a1 x cube plus a2 x square plus a3x plus a4 equal to 0. Okay, this has roots. The roots are this alpha plus 1 upon beta. We have written them as a, b, c and d. Okay, so roots a comma b comma c comma d, these roots are all 1 comma 1 comma 1 comma 1. Okay, these are the four roots. All the roots are identical according to given conditions. Okay, so now if we try to use the sum of roots and product of roots, okay, the sum of roots, let's say this is summation of alpha. This means basically a plus b plus c plus d. Okay, this will be given by minus of coefficient of x cube is a1, right, upon coefficient of x to the power 4. Okay, and this value a plus b plus c plus d, this is equal to 1 plus 1 plus 1 plus 1 equal to 4. So this implies a1 by a naught is minus 4. Okay, on multiplying both sides by minus 1. Okay, similarly, if we take summation ab, this means taking sum of product of roots, taking two at a time. Okay, this means one can be ab, another can be ac, another can be ad, then we can have bc, bd, and then lastly BSc AD, BC BD, and then CD. Okay, is any pair left? 4C2, 4 into 3, 6 pairs, right? Okay, so this will be equal to, the previous one was minus A1 by A naught, right? This will be plus of A2 upon A naught, that is coefficient of x square divided by coefficient of x to the power 4. Okay, now this becomes A is 1, B is 1, right? So this is 1. Similarly, all this pair will be equal to 1. Okay, 1 plus 1 plus 1 plus 1, 3 plus 3, 6 equal to A2 by A naught. Okay, so this implies your A2 by A naught will be equal to 6. Okay, so this is the answer, final answer. Okay, we were required to find the value of this A2 upon A naught. Okay, this is it. Now the extra part that I want to do is, let us find the other also. This is extra. Okay, this is finished here. This is slightly extra. I want to find the relation between the other pairs of roots. Okay, let us find summation of ABC. This is ABC plus ACD plus ABD plus BCD. Okay, is there any pair left? This is 4C3. 4C3 is 4, 4. Yes, only 4 pairs. Okay, so this sum of product of roots taking 3 roots at a time, this will be given by, it alternates between plus and minus, right? This summation A was minus A1 by A naught. Then summation AB is plus A2 by A naught. Then the next one will be again minus, and this will be minus coefficient of x, that is minus A3 upon A naught. Okay, this coefficient of x divided by coefficient of x to the power 4. Okay, so this implies product of these three all are 1, so individually each of these will be equal to 1, right? So this implies 1 plus 1 plus 1 plus 1 is equal to minus A3 by A naught. Okay, so this implies your A3 upon A naught will be equal to again minus 4. Okay, and lastly, and let us find the product of roots. Okay, this is given by pi of A. Like summation stands for sum. See, summation A means A plus B plus C plus D, and this capital pi stands for product of roots. Okay, so this means pi of A means A times B times C times D. How many terms are there? How many roots are there? If there are 5 roots, this is A B C D E. Okay, So this will be again equal to, the previous was minus a3 by a naught, right? So this will be the constant term a4 plus a4 upon a naught. Okay, this is given by a4 upon a naught. So this implies all of this product is equal to 1. So this implies a4 by a naught, this is equal to 1. Okay, so the extra things that we have got is summation a, that was a plus b plus c plus d. From there the summation was 4. So from there we got the relation a1 by a naught, okay, was minus 4. We got summation ab equal to 6, which meant a2 by a naught, which was the question that was asked. Okay, this is 6. Then we found the product of 3, sum of product of roots taking 3 at a time, abc, this was equal to 4, and from there we got a3 upon a naught equal to minus 4 again, and then product of all roots taken at a time, this was equal to 1, and this implies that a4 upon a naught, okay, this is 1. So these are the 4 conditions that we have got for the given biquadratic equation. Okay, after we found the roots to be all equal to 1, the roots were alpha plus 1, 1 upon beta minus 1, and so on. Okay, so this is it. Okay, the sum is finished up to here. You can only find this value, particular value. Okay, do note that when you take 2 at a time, you have to, it is better to write like ab plus ac plus ad. You finish all the a first, okay, then you go to b and try to finish the b first. If you write like ab plus bc plus cd plus da like that in the cyclic fashion, you might miss a few roots. Okay, so in the given question, the options, one of the options had 4 also. So if you write like that, if you write like ab plus bc plus cd plus da, you might find that answer to be 4. Answer is 6. Okay, so it is better to start with a, say, then you finish the a roots first, the product of a first, then you go to b and see if any combination of b is left, and then you do with c. Okay, in that way, if you write, your all the terms will be included. Okay, it will be exhaustive that way. Okay, so this is it, and these are some of the extra conditions that can be derived from the given condition. Okay, these are not required for the particular question consideration. Okay, so this is it. Thank you.